Just checking we got autofocus working okay. Right, I'm just going to go for this. I don't want to do any editing, so there's been a few questions about the new Kite 3. So anyway, I'm just going to show you the motor pods and how they have evolved over time. The first ones for the first Kite were very simple, and the ESC was central. It is a 4-in-1 in the middle of the Kite, so obviously 3 motor wires coming from each side. The old tail servo needed the lugs cutting off. Some people weren't happy with that. The first Kite 2 had the system with the indexing, so the nose moved and it caught on this disc, but only in reverse. I'm sure there's you can go back and check my other videos to see how that worked. This was ESCs, Vimdrones ESCs in each pod. They connected to the main wing through this thing, and this was working on a 5S system. The first one was a 14mm tube. This has gone up to 16. And now to the Kite 3. Again, 16mm tube. The same Vimdrones ESCs in there, but this time we're using the MAD components 4112 self-aligning motor. So that's supposed to work like that. This one seems pretty good. I've got one of them that is sometimes stopping in other places, but this one seems pretty good. What else? Yeah, so the rear pod, I hope I'm in shot there. The rear pod is disconnectable on this one, as the front ones. Of course, once you clip that on, you've then got to pop that on the bottom. I'll take that off for the test. Of course, the front ones, as before, had a single kind of locking M3 in there, so they popped off fairly easy. Right, so there's been a lot of people suggesting that this clearance here. Let me just check we're getting a good focus. Not so bad. They're suggesting that this clearance is not enough. Well, of course it's going to not have great efficiency over this portion of the disc, but it's not much of the disc. I don't know how many percentage of the swept area, but it's not very much. I think it may increase the noise a little bit. It may buzz as it passes there. Flex, yeah, you can just bend it down. It's taking quite a lot of force. You can just make it touch there. I think once it's spinning pretty fast, the centrifugal force will try to keep it straight, and anyway the lifting force will be bending it in the other direction. Motor cooling, they are getting a little bit warm with a prolonged spin up. We might try that in a moment. The airflow, I've increased the gaps here. It's a sort of centrifugal fan idea, so this thing is hollow and the ESC in there, so in fact I can show you here. This one's got the cover off, obviously. The air blows out quite strongly from the tops of these motors, so it's directed over the ESC, and these side vents hopefully will help with the airflow. So as the downwash from the prop blows over there, the theory is that it will also suck the air out. The ESCs seem to stay well cool. The motors are getting a little bit warmer at a prolonged test, but I don't anticipate VTOL flight lasting too long. Well, so we can try and test this. I'll get it in the vise. These things are just perfect. They're for cleaning a gun barrel, but they're for 16mm, so they just fit perfectly. Let me just spin you around a minute. Are we on the vise there? I've had to shut the garage door, the light very bright today, it was playing all tricks, so we're shut inside at the moment. So that seems okay. Of course, in flight it would be attached here, so there'd be a very short moment arm. But being attached to the vise right back here, there's quite a lot of bounce going on there. But of course, that's not going to be a problem in flight. Excuse me, keep checking the. Yeah, I think you can see all of that. Right. So what we've got here is. This is how it will be attached inside the wing with one of these things. This wire is much too small though, it's only 18 gauge. I'd probably be using 14 or 12 inside the wing. So that pops in there like that. Every time you connect it to the wing, that connection will be made. We've got battery voltage, of course. We've got CAN ground, CAN low and CAN high. So that goes into CAN, what do they call it, a hub distributor thing. And we've got an ancient Pixhawk here. So let's power all of this up. Probably better if I move over to the laptop now. Stand by. I know it's not great filming a laptop, but well, that's the way it is. Okay, so we're connecting the Pixhawk. Come on. Why does it always take 3 goes to get a USB in? Connect. Okay, looks like it's happy. Is it? Yep. You see I've got this set up for when it's in the aircraft. I can read 5 different ESCs, of course 4 lift motors and one propulsion motor. Of course, we've only got one connected today, but this is how good the CAN bus ESCs are. You've got all of these off each ESC, volt, current, RPM and temperature, and I'm quite happy that these are very accurate actually. So let me just go back and make sure nothing's going to go wrong over here. Just talk amongst yourselves for a minute. Right, I've just taped the wires down, connecting battery power to the ESC. Hopefully we'll have a little happy noise. There we go, sounds good. Now I'll show you the beauty of CAN bus. A bit more jiggling around so I can get in there. So if we go to setup and optional hardware, hold on, something quite right. I don't think we've got that quite right yet. Let's try that again. There we go, that's what I wanted to see. So we've down in the optional hardware we've got the drone CAN. Click on there and then we're on CAN 1, Mavlink CAN 1. If we're lucky we get the Vimdrones ESC coming up there. We can see the parameters. So for me this is fantastic, not having to fight with connecting with a pass-through, what have you. You've got all the parameters there. Of course, if there was 5 or more, if there was more ESCs, then you'd get the choice of viewing the parameters on each one of them. So I've set this up for this motor. It's 450 kV. For some reason it's it just lets me put 420 in. And we should then be able to go to setup and motor test and stand by. Is everything looking safe and connected? Is the vice tight enough? Nothing on the bench going to blow away, so you'll hear it, and I'll turn it around in a sec. Motor A. Okay, look at that. Testing motor A. Nice. Since I probably have not got too much battery in this camera, I'll try a 50%. 50%, and we'll do it for 10 seconds. And as soon as I've pressed the test, I'll move to the other screen, and you can see the telemetry coming off the motor. This is going to be a bit noisy. So voltage, current, RPM and the ESC temperature. Okay, back to setup. So I think the buzz was probably because the motor arms are, or the pod is quite close to the propeller, and I think that's probably causing a bit more of a buzz, but there's no vibration. It's producing lots of lift. It's trying to lift up the carpet in here. So let's just go for a 100% for 10 seconds. Yeah, everything looks good. Okay, I expect you want to see that. I'll do that one more time. How warm's that getting? Well, it's not stone cold, but not too hot. So here we go, same test, 100%, 10 seconds. Ready, Eddie. Why do I find that so funny? Well, I hope you enjoyed that. Not much more to say. There doesn't seem to be a huge problem with having that gap so small. And after all, it's not like it's a quadcopter going to be spending a long time with those motors running. I generally, my takeoff run probably lasts longer than 15 seconds. If you look back on some of the other videos, I get up maybe less than 20 meters and give it FPWA, and there you go. So I'm quite happy that these are going to be okay. Thanks for watching.